What is a CDN? Why should we developers take advantage of it? Let's take a look. Content Delivery Network has been around since the late 90s. It was developed to speed up the delivery of static HTML content for users all around the world. What can a modern CDN do for us? Let's take a look. At a fundamental level, CDN brings content closer to the user. This improves the performance of a web service as perceived by the user. It is well documented that performance is critical to user engagement and retention. To bring service closer to the users, CDN deploys servers all over the world. These server locations are called point of presence or POPs. A server inside the POP is now commonly called an edge server. Having many POPs all over the world ensures that every user can reach a fast edge server close to them. Different technologies to direct a user's request to the closest POP. Each POP has its own IP address. When the user looks up the IP address for the CDN, DNS returns the IP address of the POP closest to them. With Anycast, all POPs share the same IP address. When a request comes into the Anycast network for that IP address, the network sends the request to the POP that is closest to the requester. Each edge server acts as a reverse proxy with a huge content cache. We talked about reverse proxy in an earlier video. Static contents are cached on the edge server in this content cache. If a piece of content is in the cache, it could be quickly returned to the user. Since the edge server only asks for a copy of the static content from the origin server if it is not in its cache, this greatly reduces the load and bandwidth requirements of the origin server cluster. A modern CDN could also transform static content into more optimized formats. For example, it could minify JavaScript bundles on the fly, or transform an image file from an old format to a modern one like WebP or AVIF. The edge server also serves a very important role in the modern HTTP stack. All TLS connections terminate at the edge server. TLS handshakes are expensive. The commonly used versions like 1 to take several trips to establish. By terminating the TLS connection, it reduces the latency for the user to establish an encrypted TCP connection. This is one reason why many applications send dynamic and catchable HTTP content over the CDN. Besides performance, CDN brings two other benefits. First is security. This is the key to providing effective DDoS protection against large-scale attacks. By having a network with a capacity much larger than the attackers. This is especially effective with a CDN built on an Anycast network. It allows the CDN to diffuse the attack traffic over a huge number of servers. Second, a modern CDN improves availability. CDN by its nature is highly distributed. By having copies of contents available in many POPs, CDN can withstand many hardware failures.